Hello, Algebra 1B students. Welcome to our final video of Chapter 8. We're going to extend our factoring a little bit by factoring cubic polynomials, which means something to the third power today. So we're going to start with a warm-up here. We're going to need to know the GCF, or the greatest common factor of different terms, a lot in this section. It's the crucial piece of being able to factor these polynomials with degree 3, meaning an x to the third power. So let's look at finding the greatest common factor of the following expressions, starting here with number 1. Now, the first thing that I look for when I'm finding the greatest common factor is I look for variables and how many there are in each term. Well, I see right here on my 7x squared that I have x squared, which means 2 x's. And on my 35x to the third, I have 3 x's. How many of those are common to both? Well, if one has 2 and the other has 3, then they both have at least 2 x's, so I can take out an x squared. Okay? I don't see any other variables, so I'm going to look now at my numbers, 35 and 7. Well, I know that 7, well, that's 7 times 1, and I know that 35 is 7 times 5, which means 7 is common. So I will put 7x squared right there as my greatest common factor. In number 2 here, I have 24x and I have 9. Well, first thing I'm going to look for is variables. Unfortunately, my 9 right here doesn't have any, so there is no variable in common here, no x's that I can pull out. But I do see that 9 is, I believe, 3 times 3, and 24 is, I believe, 3 times 8, which means I have a 3 that is common here to these two. And if I fully factored the 24, obviously, I would have 3 times 2 times 2 times 2. But still, I have just one 3 that is common to both here and here, which means my greatest common factor is 3. Okay? Hopefully you're feeling okay about finding the greatest common factor of things. If you're not, that will become apparent when I give you an example to do from this section 8.8. Now, the entirety of what I am asking you to do from section 8.8 is something like this. What is the factored form of this kind of equation? 3n to the third minus 12n squared plus 2n minus 8. I'm going to factor that into 2 pieces in parentheses like we have been doing. Okay? And I have 3 steps to help you do that. 3 steps. Step number 1 is to group the first 2 terms together and factor out the GCF. Okay? So my first 2 terms, of course, I mean the first term and the second term here, my n to the third and my n to the second power. So I put that down here. So that is what we're working with now. 3n to the third and 12n squared. The minus sign in the middle will become important in a second. It is not right now. If I want to find the greatest common factor of those 2, again, first thing I look for is variables. I see n to the second here, and I see n to the third right there. So I believe 2 of them are common, so n squared is going to be involved in my greatest common factor. Then I look at my numbers, and I know that 3 is 3 times 1, and 12 is 3 times 4, which is 3 times 2 times 2. So 3 times 1 and 3 times 4 means a 3 is common to both. So my greatest common factor is 3n squared. Now, the rest of step 1 says factor out the GCF. So once I have found the GCF, I'm going to write it as GCF times whatever is left. Okay? So if I pull out 2n's from my n to the third right here, how many do I have left? Just 1. That's an n. And I only have this 1 left here for my number. So 1n, I'll just leave it as n. In my second term here, if I pull out n squared from n squared, how many n's do I have left? I have none left. There were 2 there, and I took them both out. So I have none left over. And the number that I have left over is right here. That's a 4. So n and 4, and now is where my minus sign becomes important. Because there was a minus sign here in between them, I will put a minus sign in between them again. There we go. 3n squared and n minus 4. I have factored out the greatest common factor from these first 2 terms here. Okay? That's step 1. Step 2 is to group the second 2 terms together and factor out the GCF. This means do exactly the same thing that you did in step 1, but now instead of 3n to the third and 12n squared, now I will be working with 2n minus 8. 2n and the 8. So the first thing I look for when I want to find the GCF, again, is variables. In 2n and 8, the 8 doesn't have any, so there are no variables I can pull out here. No n's to be pulled out. In terms of numbers, I know that 2 is 2 times 1, and 8 is 2 times 4. So I am going to pull out this 2 right there. That is my greatest common factor, just the 2. No n's involved at all. And now, once again, I will factor that out and put what is left in parentheses. So if I factor out my 2 from the first term, I have a 1 left over. And I do still have an n here attached. So I'm going to have 1n or just n. And then from my second term, from my 8, once I have taken a 2 out, I have 4 left over. And again, because there is a minus sign here in between when I started, I will leave a minus sign in between there. Okay, so now I have grouped the second 2 terms and factored out the greatest common factor of those 2 terms. Step 3 will be the end. And that is to factor out what's left over. Okay, so let me just recap what we have so far. What have I done to this equation? I now have a 3n squared parentheses n minus 4 plus 2 parentheses n minus 4. You can see that what I have left over in these 2 parentheses sets, here and here, they are exactly the same, which means I can factor that out. So I will put in parentheses the n minus 4, and then I will put in parentheses the other 2 pieces that are multiplied on. These 2. Okay, so I'm going to put parentheses 3n squared plus 2. 3n squared plus 2, because that was what I had attached to my n minus 4. And my other set of parentheses will remain n minus 4, and I have now done it. I have factored that big long equation into these 2 pieces, one in blue and one in red. Okay? What I want you to notice, this first piece is the GCFs of the first 2 terms and the second 2 terms. That is the GCFs. And this is what's left after I factor out that GCF. Okay, so it's the GCFs together in parentheses times by what's left over once I have done that factoring of the GCF. Okay? If you have questions about any of those three steps, by the way, those three steps are what I'm looking for in your notes tomorrow. If you have any questions, make a note to ask me in class tomorrow. Otherwise, that's it for this section. I do have one problem I would like you to do here. What is the factored form of this big long equation here? 8t to the third plus 14t squared plus 20t plus 35. Factor that using our three steps, and then you will be all ready for your practice problem set tomorrow. So pause the video, take a look at this problem. If you want it in your book, it is right at the bottom of page 529. Factor that into two pieces in parentheses, and then come back and I'll show you the answer. So pause the video, take a look at that problem, and then we will be done. Okay, what we should get here is 2t squared plus 5 times 4t plus 7. 2t squared plus 5 times, in parentheses, 4t plus 7. If you have questions about that, make a note to ask me in class tomorrow. Otherwise, that's all I have for you right now. Have a great night.